Hello, Assalamualaikum. My name is Fazlin Binti Asni, and today I will present to you about the usage of Carnegie Learning Cognitive Tutor among students in mathematics education during COVID-19. Cognitive Tutor is a blended learning that combines textbooks and software activities designed by Carnegie Learning. It provides students an opportunity to learn and improve their performance in mathematics, especially during COVID-19. As we know, this pandemic COVID-19 causes all students to learn through online, which is more challenging because they need to face different obstacles in their course of studies, such as lack of sufficient time for study, do not have enough study materials, have difficulties to access and use the ICT, and get ineffective feedback. Based on our objective, there are three types of cognitive mathematics that have been used in real mathematics classrooms, such as Cognitive Tutor Algebra 1, Cognitive Tutor Geometry, and Cognitive Tutor Algebra 2. Cognitive Tutor 1 I use a mastery learning and blended learning approach. Based on the results of achievement gains from assessment in Milwaukee, Cognitive Tutor Algebra 1 students perform 25% better on standardized test questions than comparable students in traditional Algebra 1. Also, 50% of students in Cognitive Tutor Algebra 1 are better on solving and reasoning the problems among the multiple representations. Cognitive Tutor Geometry is a secondary mathematics published by Carnegie Learning, which has been designed to enhance students' understanding on geometry concepts. It also uses the same computer-based tutoring approach as Cognitive Tutor Algebra 1. This software provides tutor agent called Help Tutor to teach users about help-seeking skills by giving metacognitive feedback. It also has cognitive model to track students in their various approach through this problem to estimate their knowledge level and also provide domain level feedback by giving hints if needed. Cognitive Tutor Algebra 2 is a part of the complete Carnegie Learning within the scope of secondary mathematics, which includes Algebra 1, Algebra 2, and Geometry. Cognitive Tutor Algebra 2 students scored 2% correct on pre-test that preceded the Cognitive Tutor lesson and scored 52% correct on the post-test. In a 1,998 until 1,999 assessment, Cognitive Tutor Algebra 2 students score 54% correct in a year in assessment, while comparable students in traditional Algebra 2 course score 8% correct only. Next, this technology basically gives many positive impact towards students, especially on their mathematics education, since students will interact with the computer interface that can help them to solve the complex problem activities, since model tracing will guide them by giving some hints if needed. It also can trace students' individual problems and give them feedback about their skill through bar chart called Skillometer. Unconditionally, it also can give more space for teachers to give their attention to the students who are struggling and need most help. Cognitive Tutor also allows students to have personal environments, since students have their own session and track personal individual progress. So, students can reduce their embarrassments and free expression of negative effect if they have a bad performance or they make a mistake. Otherwise, they will reflect on their own mistake based on their skill achievement record. Next, SimStudent is a machine learning agent and outgrowth of Cognitive Tutor authoring tools to help authors to create an expert model for a cognitive tutor without heavy programming. There are two ways to author an expert model with SimStudent, which are: first, authoring by tutoring. The author will interact with SimStudent by posing the problem to the SimStudent to solve, then author will give the feedback to the steps performed by SimStudent, whether it's positive or negative. If it's negative feedback, the author will demonstrate the right step if SimStudent requests the hint. Second, authoring by demonstration. Author will just demonstrate the right solution based on the problems to the SimStudent, and it will generalize the step given without giving any feedback. Authoring an algebra tutor with SimStudent is more efficient than authoring an equivalent tutor using example tracing, and then the model learned by SimStudent is more general. Other than that, empirical results have shown that models induced by SimStudent fit student data better than models hand authoring by domain expert, and SimStudent is more efficient. The method used for this research is by simple selection through existing data from one of the selected papers. In order to guide this data extraction, the data collection from Stephen Ritter, Joanna Kulikowicz, Pui Wale, Christy McQuarrie, and Pat Morgan 2007 was adopted. probability sampling method is conducted towards students within 14 until 15 years old in the Moray, Oklahoma Independent School District. However, we restrict our analysis to students in 3 remaining schools, which are Brink, Central, and Highland West, since some of schools do not have sufficient computer resource and did not follow the within-teacher study design. Study will measure the student knowledge by using their Semester 1 grades, Semester 2 grades, and their performance on the Educational Testing Service (ETS). ETS assessment consists of 25 multiple choice and 15 constructed response questions to assess their understanding of algebraic concept, processes, and skills, which are cover 50% of their scores. Across the 5 schools chosen, 148 students are enrolled in algebra at the beginning of the year, which 659 of them are enrolled in the 3 schools to carry out the experiment, while 426 of them are assigned to one of the 6 teachers in the experiment, and we exclude 83 of students for a variety of reasons, since it is not clear how to interpret the data from students whose classroom experience did not match the experiment design. First table shows the initial enrollment and status of students assigned to teachers in the study. Transfer represents the students who are transferred within the district to a different section of course, while dropout indicates the students who are enrolled in the district for the second semester, and no grades denote the students who are listed as enrolled for semester 1 and 2, but they do not receive their grade. Lastly, inconsistent data indicates students who have been records of a conflict between a curriculum and class assignment. Second table shows the semester 1 grade for 60 students who are excluded from the analysis. 60 from 83 students who are excluded from the analysis are received their semester 1 grades, and the means of them are already shown in the table 2 by school and identified conditions, while 11 students in this data are in the traditional condition but their class assignments are cognitive tutor class. For the result, we use hierarchical linear modeling, which is a statistical technique that accounts for variance at different levels of nested design. We analyze the data using 2-level model, with student as the level 1 units and section as the level 2 units. Dummy-coded treatment and teachers were the level 2 predictors. To calculate a standardized effect size at the student level for each dependent measure, we divide the treatment difference for that measure by the pooled within treatment standard deviation. The table shows the result of first semester grades. It were collected from 19 classes and 342 students. On this measure, the effect of treatment is statistically significant with t equal to 3.924 and our p is 0.002 with grades favoring the cognitive tutor students. The difference due treatment for this measure is 0.5, resulting in an effect size of 0.416. Next, this table shows the result from second semester grades for the same group of students as shown in previous table. The effect of treatment also reached significant with t equal to 3.316 and p equal to 0.007. The difference due to treatment for this measure is 0.43, resulting in an effect size of 0.356. Next, this table shows the result of ETS exam. For the ETS Algebra 1 exam results, the data consists of 6 teachers, 16 sections, and 2,055 students. To save money in the evaluation, only one control classroom for each teacher was randomly selected to take the ETS exam. For the ETS skill score, the effect of treatment is marginally significant with t equal to 1.89 and p equal to 0.091. The difference due to treatment is 2.13, resulting in an effect size of 0.379. On all three measures, the results support the conclusion that use of cognitive tutor Algebra 1 curriculum helps students learn mathematics. The design of this experiment allows us to make casual conclusion about the effect of the cognitive tutor Algebra 1 curriculum in student performance in their mathematics education. However, there are some factors that we need to consider since it can influence reduce a simple statement of effect size and statistical significance, such as the number of teachers in the study is too small, student assignment to classes was unbiased because it was not influenced by the study, and so on. Conclusion, this is a study aimed to identify the effective of Carnegie learning cognitive tutor that can help students to improve their mathematics education during COVID-19. Therefore, by doing this experiment, Cognitive Tutor Algebra 1 has proved that this software has shows a significant effect in high school students rather than by using traditional ways. Based on the qualitative, the study can conclude that Cognitive Tutor Algebra 1 can improve students' achievement in mathematics education.